In this video, we will derive the 6 trigonometric ratios for a 30-degree angle. Last time we did it for 45 degrees and then for 30 degrees. No, we did it for 45 degrees and then for 60 degrees. So we needed this. This is what we used for the 60-degree angle. We have an equilateral triangle. An equilateral triangle is one whose sides are congruent. So let's call it A. And not only that, it is also an equiangular triangle. So that means all the interior angles of this triangle are congruent, and that means each of them is a 60-degree angle. This is 60 degrees. This is 60 degrees. And they are congruent with angle alpha. So again, an equilateral triangle is also an equiangular triangle. We shall draw an angle bisector through angle C. Okay, angle bisector. Okay, we did this because we want to produce a 30-degree angle. So that is now 30 degrees. And you know what? Since this is an equilateral triangle, that angle bisector CD, okay, CD is also perpendicular to the opposite side. And not only that, it is a perpendicular bisector of the line AB. And so, the length of AD is 1/2 of AD. The length of DB is 1/2 of A. Now we have a right triangle that contains a 30-degree angle. So what are the 6 trigonometric ratios of a 30-degree angle? So we always go back to SOHCAHTOA. S is for sine, K is for cosine, and T is for the tangent function. Okay, so sine is opposite over the hypotenuse. Sine of 30 degrees is 1/2. How about cosine? Cosine, K, is equal to the side adjacent over the hypotenuse. It's equal to square root of 3 over 2. What about tangent? It's equal to TOA. Okay, so TOA, side opposite 30 degrees. That is 1/2 of A divided by. So what is this equal to? 1 over square root of 3. Rationalizing the denominator, this will give you square root of 3 over 3. These are the 3. We don't worry too much about the other 3 because the other 3 is just the reciprocal of these ratios. The reciprocal of your sine is cosecant. So cosecant of 30 degrees is simply 2. The reciprocal of cosine is secant. So secant, it's 2 times square root of 3 over 3. So let us show it. Let us show it. So again, we multiply by square root of 3 over square root of 3. We do that to rationalize the denominator. And what we have here is 2 times square root of 3 over 3. Okay? What about cotangent? Cotangent is the reciprocal of tangent. Three divided by 3 is 1, and so we have square root of 3. We don't worry too much about the reciprocal. Okay, what we pay attention to are sine, cosine, and tangent. So these are the special angles and the 3 trigonometric ratios. and the reciprocal is the other three trigonometric ratios. I know this is a huge piece of information. This is a huge chunk of knowledge, and some students have difficulty remembering all these trigonometric ratios. So what I do is, especially during exams, just in case I have difficulty recalling these trigonometric ratios, what I do during exams is, in one corner of my paper, I will draw these triangles. This one is an isosceles triangle. I will use this to derive the trigonometric ratios for a 45-degree angle. And then I will draw this. This is an equilateral triangle and also an equiangular triangle. And I will construct a right triangle by drawing an angle bisector through C. And that angle bisector is going to be a perpendicular bisector of this line segment. And what you would have there is a right triangle that contains 30 degrees and then 60 degrees. And then to produce your trigonometric functions or your 6 trigonometric ratios, all you have to do is go back to this. SOHCAHTOA.